We are starting a new topic in this class, and which is about string matching. In this class, we shall see basically what this problem is, and also we can look at a very naive algorithm for solving this problem. So, the topic for today is string matching. To start with, let us try to look at this problem. So, what is string matching? It is the process of finding all occurrences of a pattern in a given text. We can try to use an example to understand what it is. Given a text like this, and in general this could be a complete textbook or a page in the internet or any text input for that matter. And not only the text is given as input, one more input is there, which is a pattern, and given a pair of input, that is a text input, that is a document on which you are searching for a pattern. And string matching is the process of finding all the occurrences of the pattern in the given text. For example, here these are the different occurrences of this pattern in the given text. Another example, on the same input text, if you look at the pattern as ITE, then the string matching problem should find all occurrences of this pattern in the given text. In this case, only 4 occurrences are there, and which is now shown in the screen. So, basically string matching is the process of finding all occurrences of a pattern in a given text. Now, we can look at some applications for string matching. First one, text editing programs. Maybe you have a text editor like gedit or WordPad, where maybe you have to find and replace all occurrences of a string with some other string. So, that is an example application. So, another one is most popular nowadays, search engines. If you use any popular search engines like Google, when you want to utilize the service of Google search engine, so what you are expected to give as input is a pattern representing what you are searching for. So, without knowing that it is formally a pattern, you are typing a part of what you are looking at, or some keywords or whatever. So, that is again an application where you are giving a pattern, or whatever you type as a string on the search window is what is called a pattern. And basically what is happening behind the scene is pattern matching or string matching. Another example is finding patterns in DNA sequences, and N is missing here, sorry for that. So, these are all very common applications, and hence naturally we need an efficient algorithm for string matching. So, not only finding the solution is important, but also the time for doing it is also very important, because it's a common process in most of the recent applications in computer science. Now we can try to look at it more formally. Basically, it is the process of finding the occurrences of all occurrences of a pattern in a given text. Now we are going to formalize it. Consider the input text as a single dimensional array of n characters. Example, here an array of 13 characters is given. So this could be an input text, or if you consider the first paragraph, that also can be represented as a single dimensional array of characters, and there are n characters is what is assumed for some natural number n. And the input pattern can also be considered as a single dimensional array P of m characters, such that the number of characters in the pattern must be less than or equal to number of characters in the input text, because there is no meaning in searching for a pattern which is of length more than the input text itself. So this is a natural requirement. An example pattern is ABAA, and occurrence of this is shown here. Let sigma be a finite alphabet set from which both the input text and the pattern are formed. For example, here sigma is set ABC. So the only point to note here is same alphabet set for both text and pattern, and that makes sense because you are searching for that pattern in the text. And formally, the set of all possible strings over an alphabet set sigma is denoted as sigma star, the set of all strings over sigma. For example, given sigma as set ABC, sigma star can be this set, or it is this set, where what is epsilon? It is a string of 0 simples called the null or empty string. No simples are there, so it is a notation. A string of no simples followed by a string of 1 simple followed by strings of 2 simples. Likewise, you can list them in a lexicographic order if you want. So that is the set of all possible strings over an alphabet set, that is concatenation of 0 or more simples from the character set or alphabet set. If you don't take any characters, then you are getting null string. Now, a pattern P of length m occurs with a shift S. This is a very important concept for string matching algorithms. An example can make it very clear what is a shift. A pattern of length m occurs with a shift S if from the next position from that shift is an index, or shift is a natural number. So after that many characters, the next m characters in the text are going to be the characters in the pattern in the required order. Example can make it more clear. Here a text input is given and a pattern is given, and you can easily see that this pattern is occurring in the text from index 4 to index 7. Then you can say that the pattern is occurring in the text with a shift 3, means if you shift 3 positions to the right, then from there onwards you can see the pattern is what it is saying. That is the meaning of shift. it is a number. So after that many cells in the input array, you can find the pattern. Okay, that is a shift. And if P occurs with the shift S in T, then it is called valid shift. For example, S is equal to 3 is a valid shift, and otherwise it is called an invalid shift. For example, S is equal to 3 is a valid shift because after 3 the next 4 characters match with the 4 characters in the pattern. If that is not the case for a given shift, it is called an invalid shift. So these are concepts that the algorithm is going to use. And now you can formally define string matching as the problem of finding all valid shifts with which a given pattern P occurs in a given text T. For example, here there is a valid shift of 3. If you shift 3 positions to the right, what you are getting in the next window or the next m positions is the pattern. Now, before we proceed and look at the naive algorithm for string matching, let us see some more aspects of this problem. Now we are going to look at some notations. The length of a string denoted as modulus x is the number of characters in x. For example, given x as ABAB, the length of x is 4, and this is how it is denoted. Concatenation of the strings x and y is denoted by x dot y or simply xy, and the length of xy satisfies this property. Length of the concatenation of x and y is the sum of the lengths of x and y. Example, suppose x is ABAB and y is BAB. What is their concatenation? ABAB BAB. And you can easily see that here the length is 7, and which is 4 plus 3, and that is true in general. And a prefix y of a string x is denoted as this. Y is a prefix of x. This is the notation. So a prefix is a string of 0 or more leftmost simples from x for x. That is, it is a sequence of 0 or more simples from the left side of that string. So, if y is a prefix of x, that means x can be written as the concatenation of y with some other string z. So, y is a prefix of x. Hope you are getting it. Example, when x is equal to ABAB and y is a prefix of x, then what could be y? Y can be 0 or more simples taken from the left. When you take only 0 simples, epsilon you are getting. 1 simple, then 2 simples AB, 3 simples ABA, 4 simples ABAB. These are the prefixes. So, given a string of length n, there are n prefixes. I hope you are getting what are prefixes. Similarly, you can define suffix. A suffix y of a string x denoted as this, y is a suffix of x, is a string of 0 or more rightmost simples from x. So, here you are picking it up from the right side. So, if y is a prefix of x, suffix of x, then you can say that x can be written as z followed by y for some z. That means y is a prefix, y is a suffix. Example, for the same input, which are the suffixes? 0 simples from right side is epsilon, 1 symbol is b, 2 simples from the right is AB, 3 simples is BAB, and 3 simples is AB, sorry, 4 simples is ABAB. So, see, these are some basic concepts and notations that we need for our algorithm. More notations. Now, if y is a prefix of x or y is a suffix of x, then you can see that the number of characters in y is less than or equal to the number of characters in x. Then only y can be either a suffix or prefix of x. Also, if y1 is a suffix of x and y2 is also a suffix of x with the length of y1 less than or equal to length of y2, then you can see that y1 is a suffix of y2. Why? You can look at an example. See, BBA is y1, which is a suffix of x, and y2, which is BABBA is again a suffix of x. Then depending on their length, if y1 is length of y1 is less than y2, then we are claiming that y1 is a suffix of y2. That is true for this particular example, and in general you can say x is this, and suppose y2, the length of y2 is more, is a suffix of x, and you already know that suppose y1 is also a suffix, then definitely the characters here and there match, and the same happens here as well. So y1 must be a suffix of y2 as well, and that is what we are claiming here. So y1 must be a suffix of y2 in this particular case. This is the other case. Suppose y1 and y2 are prefixes of x and y2 is less than or equal to y1. This time y2 is less than or equal to y1. Then you can see that y2 is a suffix of y1. Okay, that is you can easily observe that it is correct. And another point, if y1 and y2 both are suffixes of x and they are having the same length, then y1 must be is equal to y2. We can easily see all these properties, and similar properties like this are satisfied by the prefix relation as well. Now, a k character prefix of a pattern P is denoted as P subscript k. That means the k leftmost simples from P. Example, if P is BABA, what is P0 is epsilon. Regardless of what P is, if you are looking at P0, is epsilon. And P3 means you take 3 symbols from the left, it is BAB. So what would be PM? M is the length of this pattern is 4. What is P4? It is BABA. Okay, that is how you use subscript to represent the prefix of a pattern. Similarly, a k character prefix of a text T is denoted as TK. Example, suppose the text is given as this string, and what is T0? T0 is null string, and what is T5? T5 is you take it from the left 5 simples ABABA, that is what you are getting. And if you look at T subscript, the length of the string T, then you are getting ABA, BA, BBA. Okay, because that is the entire text, because you are substituting n as the maximum value. Now we can say that string matching problem is to find all valid shifts such that P is a subscript of Ts plus 1. This is a prefix of the text. So, what basically we are saying is that, maybe the example will make it clear. Suppose T is this input and pattern is BABA, BABA, there is a single occurrence, and we can have shift as 1, because after the first index, after 1, if you look at the next 4 characters, this is exactly the pattern. Yeah, then we can now look at very simple and straightforward or naive string matching algorithm. And what is it doing is, it is taking a text input and a pattern input as input to the function. Then it gets the number of elements in the text or the number of characters as n, and the number of characters in the pattern as m. And we know that always m should be less than or equal to n. And now you are going to systematically check whether there exists some occurrences of the given pattern. And you are going to find all valid shift. Shift means a number, and if you shift that many times, one cell at a time, in the next m positions you will get the pattern occurring. And so you can easily see that the valid shift values are varying from 0 to n minus m, because if you look at n minus m plus 1, the next value, you will not get a valid shift that you can prove. So, what you are doing, for every possible value of shift, you are checking whether the taken value of S is a shift or not. For all I in the set, which is the set of all indices for this array pattern, so you are checking whether the pattern is occurring in the text just after the shift S. If it is so, then print that pattern occurs with the shift S. If the verification fails, then you are not going to print anything for that particular case. And you can easily verify that the complexity of this algorithm is theta of n minus m plus 1 multiplied by m. Why? Because this for loop is going exactly for n minus m plus 1 step, because it starts at 0. And what is this if doing? It is actually a loop for every value of I from 1 to m. It is checking whether t s plus I is same as pi. So, that is a pattern matching. That is exactly the pattern matching. And so, this goes for m times within a loop, which goes for n minus m plus 1 time, and that is why the complexity in the average case is taken as this. So, today we started discussing about the string matching problem. We defined it, what the problem is. Given a text input and a pattern input, it is a process of finding all occurrences of the pattern in the given text. And we also have looked at some notations and a basic naive algorithm. In the next class, we can see more about string matching, and with this now we can finish. Thank you.